Hi everybody. New/old SAT type, certain types of algebra questions probably will not go away. This is more skill-based, applying exponent rules, and the level of difficulty is fairly high. If 5 to the 2x equals 4, what is the value of 5 raised to the 3x minus 1? And if this were a grid-in question, if that format is going to be continued, which we expect it will, this could be a non-calculator question. So let's approach it that way. Little review of exponent rules here. I've written a couple of these rules in reverse order from the way it's normally shown, and it's good for students to feel comfortable with these rules in both directions and review, review, review. Step 1, we have 5 to the 2x equals 4. Solving for x directly would involve working with a graphing calculator, logs, and so on, but that is not necessary in this question. So we're going to rewrite the exponent, the power expression, as 5 to the x squared equals 4. Can you see which rule we used here? There we go. So we have a product of exponents, 2x, and we rewrote it as 5 to the x squared equals 4, taking the square root of both sides. We have 5 to the x equals 2. No plus or minus 2 here because 5 to the x exponential functions cannot be negative. So, of course, depending on the base. Continuing now, we're looking at 5 to the 3x minus 1. So this requires manipulative skills, strong algebra skills. We're going to rewrite this as 5 to the 3x over 5 to the 1 using the third rule down here. We're going to go back to the first rule that we use, rewrite this product of exponents here as 5 to the x, stack up exponents, power of a power, 5 to the x cubed over 5. And now substitute our value for 5 to the x. So we have 4, well that's a mistake, 5 to the x is 2, so ignore that. So replace 5 to the x by 2, raise it to the third power over 5, so we have 8 over 5, or 1.6. The ability to see a procedure like this, to come up with this under pressure, requires strong algebra skills, review of exponent rules, which will always be needed, and facility. And if you're not challenged with difficult problems, then it would be not that easy to come up with this under pressure. If it's one of the last couple of questions, time is running out. Again, we had a condition, an exponential type equation, but they were not asking us to solve for x, they were asking us to solve for another power of 5, and that led us to not solve for x, but to solve for 5 to the x. That was the key step here. Applying the rules of exponents, we isolated the power 5 to the x, and then we used that power 5 to the x here. Again, applying a couple of different rules of exponents. Thank you.